Okay, today you are going to be learning about linear equations again. Most linear equations have only one solution, but there are an entire set of linear equations that have no solutions, and another entire set of linear equations that have an infinite number of solutions. Here is a linear equation. You are familiar with it. First, I'm going to solve it algebraically. Okay. I don't like those fractions, so I'm going to get rid of them. 7 and 2 both go into 14, so I'm going to multiply everything by 14. Okay, 14 divided by 7 is 2. 2 times 3 is 6, so we'll turn it into negative 6x. 14 times 3 is 42, equals 14 times a half is 7, so 7x. 14 times 16, I'm taking out my calculator. 14 times 16 is 224, so plus 224. Okay, well, I like to get rid of negatives first, so negative 6x, so plus 6x, plus 6x. 42 equals 13x plus 224. Number over here, so I'll subtract the number. 224 minus 224. Calculator again. 42 minus 224. Negative 182. Negative 182 equals 13x. Divide both sides by 13. Negative 182 divided by 13. Negative 14. So negative 14 equals x. Okay, I have to check it. Now remember, I can't check it in my changed equation. I have to check it in the original equation. So I have to go all the way back to the beginning. And I'll write down negative 3/7 times negative 14 plus 3 equals 1/2 times negative 14 plus, get rid of that, 16. Okay, solve it. Let's see if this works out to be the same thing. Negative times negative is positive. 14 divided by 7 is 2. 2 times 3 is 6, so that's 6 plus 3. 1/2 of negative 14 is negative 7. Negative 7 plus 16. 6 plus 3 is 9. Negative 7 plus 16 is also 9. So it works out. That's the correct solution. The solution, if I were to write it as coordinates, would be negative 14, positive 9. Notice, I just wanted to point out that I have this middle step here in the check step. I want you to show that middle step. So make sure you have it in it. What does this look like in an equation? Well, okay. In a graph, rather. Well, negative 3/7 x plus 3. So I go over to positive 3. Negative 3/7. That's less than 1, which means I go more to the right than I go down. So over 7, down 3. Over 7, down 3. That's off the graph, so I'll draw that part of the line through there. Arrow. They go in the other direction. Over 7, up 3. Over 7, up 3. And that's off the graph, so I'll draw in this direction. Okay, see the other part of it. Up here. 1/2 x plus 16. 1/2 x plus 16. Okay, I'll just change colors. 16 is way up here. And it's positive 1/2. 1/2 is less than 1, so I'll go more to the right than I go up. So 1/2, 1/2, 1/2, 1/2. And I'd just like to show you this. See the way it goes up less than 1 whole? It only goes up 1/2 of 1 at 1. Okay, 1/2, 1/2, 1/2, 1/2. Should be a little more careful. 1/2, 1/2. There's my point of intersection. 1/2, 1/2, 1/2. Draw the line. There's my point of intersection. What are the coordinates of that point? Well, negative 14, positive 9. And what did we say was the solution? Negative 14, positive 9. I don't have to do the check step again. I did it right there. So, when you are showing your work and solving an equation, this is the type of work I expect to see from you. You can show me multiplying by the correct number. I got that by 7 times 2 is 14. Showing all the steps, showing the correct check step. There's the solution written as coordinates. I will not be asking you to graph. I just wanted you to see what it looks like. All right, next equation. There's an equation. Looks a little funny. I don't like fractions. Both denominators are 5, so I'll multiply everything by 5. Positive times negative is negative. 5 divided by 5 is 1. 1 times 6 is 6. Plus 5 times 10 is 50. Positive times negative is negative. 5 divided by 5 is 1. 1 times 6 is 6, negative 6x. Positive times negative is negative. 5 times 3 is 15, so minus 15. Okay, let's add 6x to both sides. All right, so these two cancel, leaving 50. These two cancel, leaving negative 15. I don't have any x's left. So all I'm left with is 50 is equal to negative 15. 50 doesn't equal negative 15. This is an example of when there are no solutions. When you get a statement like this, where one value equals another value that is not the same, you know that this equation has no solutions. And this is the type of work that I want you to show. I want you to get down to the statement where one number equals another number that's not the same. Then you can write no solutions. There is no check step because there are no solutions. I wanted you to see what this looks like in a graph. I won't be asking you to graph, but I want you to see what it looks like in a graph. Negative 6/5 x plus 10. Okay, so we'll start off at 10. Negative 6/5 is more than 1, so that means I will go down more than I will go to the right. Negative 6/5. Negative 6/5. Negative 6/5. Negative 6/5. Draw the line. Off in the other direction. 5, 6. And off the graph, so this way. All right, now back to the equation. Negative 6/5 x plus or minus 3. So back to the graph. Start off at negative 3. Negative 6/5. Oops, come back here. There we go. Negative 6/5. Negative 6/5, and off the graph, so draw the line. And we go in the other direction. 6, 5, 6, 5, 6, 5, and off the graph. Draw the line this way. And then we just have to find the point of intersection. Hey, look, they're parallel. They don't have a point of intersection because parallel lines will never cross. They remain the same distance apart from each other at all times. That's why this equation has no solutions. Look at this equation. The slope of this side is negative 6/5. The slope on this side is negative 6/5. They have the same slope. When they have the same slope, they might be parallel. They're going in the same direction, which means the lines are going to be parallel. But the reason you know it has no solutions is this statement right here. 50 equals negative 15. We have a statement that shows that they have no solutions. One number is equal to another number that's not the same. That's why we know it has no solutions. It looks like this in the graph because they're parallel. They have no point of intersection. All right, here is another equation. Look, they have the same slope. They're parallel. Well, not really, but you'll see in a moment. Okay, I don't like fractions. The denominator is 2, so I will multiply by 2. 2 divided by 2 is 1. 1 times 7 is 7. That's 7x. 2 times 3 is 6. Again, 7x. 2 times 3 is 6. Subtract 7x from both sides. I get 6 equals 6. Well, that's true, but what value of x makes it true? Well, all of them do. When you get a statement, when you're in the middle of solving and you get a statement where one number equals itself, you know that this has an infinite number of solutions. Every single value of x will make these equal. It doesn't matter what you use. Let's see what that looks like. Well, 7 halves x plus 3. Okay, I'll go up to 3. Make my dot. 7 halves is a lot more than 1, so I have to go up 7 over 2. Up 7 over 2. That'll be off the graph, so I'll draw the line. Go in the other direction. 2, 7. Is that 7? Yes. 2, 7. 2, 7. That'll be off the line. Draw the line. Okay, switch colors. Now we'll do the other half of the equation. 7 halves x plus 7. Okay, plus 3. 7 halves x plus 3. Okay, let me go to 3. That's on the same dot. 7 halves 2. That's on the same dot. That's on the same dot. That'll be off the graph. Let me go in this direction. That's on the same dot. That's on the same dot. 7, 2. That's on the same dot. That's why this has an infinite number of solutions. These two halves are exactly the same as each other. It doesn't matter what value you put in them, you're going to get an equal value on each side. It does not matter what the value of x is. What happens in the graph is you end up with two lines that are on top of each other. It's not really two lines, it is one single line. How you know algebraically is you get a statement like this, 6 equals 6. When you get a statement where one number equals itself in the middle of your solving, you know it has infinite solutions. All right, so one solution, you get a solution. A number equals x, x equals a number. You check it out. It all works. Graphically, they have one point of intersection. Done. No solutions. You end up with a statement where one number equals a different number. One number can never equal a different number. This equation and others like it have no solutions. Graphically, they end up being parallel to each other. Or you get a solution where one number equals itself. Well, one number always equals itself. It doesn't matter what x is equal to. It always equals itself. Then you get an infinite number of solutions. Graphically, you end up with two lines that are actually just one line, one on top of the other. So, how do I know these two? This has one solution because it has one solution. There it is. A number equals x. How do I know that this has no solutions? I have a number equals a different number. Never going to happen. How do I know this has an infinite solutions? I have one number equals itself. One number always equals itself. Infinite solutions. That's the idea. Write me a message if you have any questions.